Hello, so it's Ian. Um, Basically, I'm going to give the full rundown of how to import FDS files into Blender, as some people have requested it, and I feel like it'll do some good if people can actually use it. So, um, yeah, here we go. Um, so, first, we're going to look at the initial files that we need to from FDS. So we're going to look at the source code. Um, I'm going to be looking at this staircase file that's available online, or the tutorial, and I've modified the code. Um, I've modified the code to be able to get the output that we need to visualize the data. So first, you need to put this dt underscore plot 3d equals the frame number you want. So I've just done it at around 24.5 frames per second, and write xyz equals true, and then you need to write out plot 3d this this line to ensure that you're outputting the quantities that you want. So you don't have to put in velocities, um, heat drop or heat release or soot density. You can actually visualize any sort of data that you really want to. But I've just chosen to use the basic ones. But I'll just, in the end, well, for my visualizations, I'll just be using soot density and maybe the heat release volume rate, or heat release rate. Is that all I needed to talk about? Yeah, and so you should run the code, and um, it will basically spit out some Q. Well, what we're interested in is these XYZ files and these Q files. So the next step is you want to get onto Paraview. So um, download it if you don't have it, um, and it's free, so there's no licenses. Or I mean, I think it's open source, but just have a look into it. But it's, I think, for the most part, free. So to open up our visualization, you go open, um, you go to your file location, and you want to choose the XYZ file. And it should come out with some errors, but we don't need to worry about that. And then you go to your Q file, and this is where things get a bit tricky, and you need to set up your files correctly. But I'm just going to show you what happens when you try to import your Q files without modifying them a bit early on. So we press here. Notice how you have to import them, you have to open up all of these tabs. So you can't just click on this and import it, because when we open it, none of them are kind of chosen. Actually, I won't go into that detail, but basically, you can't do it this way. You can't import your Q files directly from FDS output. So what you want to do instead is, if we go to my copy that I made earlier, is you want to change the naming convention so that it begins with 1 in the front, and well, it has a 1 in the front, and you have enough digits to uh, to to number all of your frames in order. So I've done the Q, B, and D, but we're more interested in the Q files. So I've done that here. So it's kind of like a simulation or visual effects simulation way of doing, or way of ordering things. And this is how Paraview actually best reads the files. But it will stuff up your files. So, well, if you want to view them in smokeview, so make a copy of it before you do it. So I'll show you what we do. So let me just delete this and go to the copy XYZ file, and then we will choose the Q files. So it should pop up here, and you can just shift click to select all of them. And then you want to ensure that you click force read, because the XYZ file won't recognize how you've actually numbered the well, how you've renamed it. So you click apply, and oh, you get like this empty thing. I mean, if you play it, you're not really going to see anything, because that's not how Paraview works. But well, to make sure that your simulation is incorrectly, you can put in a clip thing, I think. And you want to adjust it to a scalar, and you can view it as, oh, that's your 5 values. Is it? I'm not sure, but we're going for density, and oh, we apply, and we can, where is it? We want to represent it as like points, just to make it a bit faster than the volume. And you can see it's kind of working. And so if we jump to frame, I don't know, 280, we can see that we have got the data. But well, the data is imported correctly. I mean, you can start playing it to see if it is in order, but you'll notice that if you just get it, I'm just reiterating, but if you get the points specifically from FDS as is, Paraview won't read your files in order. So we don't need that clip for what we're going to do. So I'll just delete that. What we're going to do is we're going to export it as a table. So if you go to filters, no, extractors, data, CSV, that's going to give you an Excel table of pretty much the whole mesh. So it's pretty intensive, but then you just go to File, Save Extracts, and then put it in the folder you want. So that's the next step of Paraview kind of done. And then now we get to the, well, you should have, once you've done that, you should have a whole data set of just well, you should have all your points labeled as a Excel file. So then you want to use Houdini, and this is where things get a bit strange, because well, it is visual effects software and you have to pay for it to use it. There is a non-commercial version, which I'm going to be using today, simply because I'm not going to be making any money off of this, and I'm just demonstrating its purposes. But if you're deciding to use it for commercial purposes, yeah, you will probably need to buy an indie version or something like that. So I'm going to show you the basic setup, and I know this is going to be more for engineers, so it might get a bit confusing, but we'll see how we go. So this is the basic setup. You want to introduce a geometry node in this box right here. To do that, you put your mouse in this box and you press tab, and that gives you the search option, and so you can search up geometry. You know, click that, and then you want to double click into the geometry node. And then I set up this VDB a bit earlier, but we'll have a look at the setup because I mean, it's quite simple in the grand scheme of things, but I guess engineers may not have seen something like this. So you want to first import your data. So if you press tab in the box again, you can press table, and you get this guy right here. So if we go to geometry spreadsheet, we can see we've imported the data, but to do that, you come up here, press this, go to your file. You can import it as, I'll just click on it. You can import it as a sequence. So yeah, then you just kind of go through, fill this out, and just to, it's pretty straightforward, but what the values you want are the naming convention. I'd be here forever if I was to explain everything, so I'm just giving you the bare bones. But the first one you want is P, which is basically points in space, with the number of attributes 3. And then you got to find your column number in your Excel file, and then you can pop out all of your points across your mesh. So the last one being the biggest extremity, and the first one being at 0. And then you want to just name it to what you want your output to be, so to say. So I'm being using density for the density, soot density. And then I'm also going to be using this made up parameter flame and I'm going to be introducing the heat release rate into this column. So so this is column 9 in the Excel sheet. The density is column 0, and the attribute length is 1. So that's just how you import the your data into Houdini from Paraview. So if we have a look at it, it comes up with a lot of points. But what you'll notice, and then, okay, I won't go into that. But the next sort of step is you want to create this VDB from particles. So this turns, let me go to the, so you want to, sorry, this wasn't really prepared to explain this. Well, the VDB from particles basically turns your point volume, your points, into a VDB, which is essentially what we're after to visualize this smoke that we're going for in FDS. So yeah, the main thing is you also want to create just a random, just a VDB file, just as a placeholder, and you want to change the voxel size to your discretized mesh. So if we go to our table, we can see that we're having increments of 0.15. So in your VDB, you want your voxel size to be the same. And then you can also add in extra attributes. So this is the density, just to fill it up. And we also have flame that we have from our table import. And so what it's doing is it's taking these values from table import, plugging it into here, and putting it into this VDB to output VDB. If we have a look at it, so it's the volume. But what you'll notice is that with the density values, at least, the walls on the building are also included in this density. So to get rid of this, we do the same thing, but instead of table importing the whole sequence, we just take the first frame. So you just import, you deselect this, you click on your first table, and you do the similar sort of setup, but instead you now pipe it into a VDB combine, and you subtract this value from this, and that's how you get your 0 value. I think that's all to really talk about. I mean, to be honest, depending on how you set up your FDS file, you'll have to change and modify your Houdini setup to output your VDB. So I can't go through every single situation, but this is pretty much the bare bones basics of how to actually achieve it. And then you want to get a cache node, file cache node, and just export it out, save to disk, and make sure you change it to a VDB, because by default it's on VGO, which you don't really want, which then gives you a whole bunch of VDBs that you can import into Blender. And I'm going to check out Unreal Engine. So if you hear more from it, then yeah, we'll probably check out some Unreal Engine. But let me get onto my fast computer, and we'll check out these files. Okay, so we're back, and here's the stairs file that I've remodeled and taken a bit of liberties in making. So putting in some exit signs, some lights. We've got the stair geometry in, and so I've also imported the VDB here. But to do it, you just press Shift A, Volume, Import Open VDB, and that gets you a file. And so I've set up a material, a really simple one. So if we go here to the shader editor, it's a printable volume one with a color ramp on the emission, with the density driving the density and the flame kind of driving the emission strength, and the black body, but black body doesn't do too much in this simulation. But we can have a little look at what it looks like. So if we go back to the timeline, and whoa, so I'll also provide a rendered look of what it might look like on the first level. But yeah, that's essentially what Blender is capable of in a nutshell, of, well, how you kind of do it. Yeah, so I mean, it's pretty cool.